Hello, everybody. How are you doing? How's it going? Good? What's good? You finished this homework. All right. Excellent. Good, good. All right. Anything else? Good?
You're back.
I'm back. I was here last Thursday. Wasn't I? I'm glad, Federico, that you're glad that I'm back, but I was here, wasn't I? Yeah, last Tuesday I wasn't here.
Wait, were you sick on Thursday?
Oh, I was here, all right, but yes, I did my office hours yesterday virtually to be safe.
So are you 100% now?
Yeah, I'm pretty much 100%. So thank you.
That's good.
Okay, that is good. That is good news. All right, well, that's good. Okay, so administratively, any questions? Okay, when's the next exam? Right before Thanksgiving. Is that a good time, bad time, or just it's a time? Oh, I'm getting ups, downs. All right. Why is it bad? No, I actually want to know why is it bad.
I have 4 other
Right after Thanksgiving.
Okay. So hold on. No. I'm trying to listen. It's not interrupt. So what's wrong with it? With the way it is right now?
It's just a
Okay, it's a packet because you have other exams. Yes. Right. Okay.
Doing it after would give us more time.
That's what I'm studying over Thanksgiving, and we can't enjoy the holiday.
Okay. So that Nice. Oh, yeah. All right. Okay. Thank you for your input. I do appreciate it. Okay. We have plenty of problems that are take home, like tons of problems that are take home, right? So I think that's what we're really doing. Okay. And I'm grateful for your feedback. Okay. I'm sorry that you have lots of exams. I don't know what to do about that.
Make sure put this one after Thanksgiving.
Do you have any other exams after Thanksgiving? Huh? Okay, look. It doesn't matter too much to me. Okay, everyone close your eyes. Everyone close your eyes. Close your eyes. Close your eyes. Everyone close your eyes. Are you hearing me? We're going to take a vote, anonymous vote. Close your eyes. Close your eyes. Close your eyes. Everyone close your eyes. Yeah, it's going to be the Tuesday, either the Tuesday after Thanksgiving or the Tuesday before Thanksgiving.
What day is before?
Okay, so close your eyes. Close your eyes. All right, now go into a nice deep trance. Ooh, this actually feels pretty good. I close my eyes too. Okay, who wants it before? Let's right now, Tuesday.
What day?
It's Tuesday. There's only one day of the week that's before. Yeah, it's Tuesday. Okay, put your hands down. Who wants it after? Yeah, okay, put your hands down. Yeah, we're going to keep it before. All right. It was actually closer than I thought it was going to be, but the before people didn't have it. Okay. All right. Okay. Okay, let's settle down. Now let's talk about what could be on the exam. All right. So we talked about when it will be. The real important question is what is on the exam. Okay. And we're going to be talking about plane stress again. And in this session, we start to talk about conditions for maximum principal stresses and maximum shear stress. Okay? So what in the world are we talking about? We're talking about starting with some general state of stress. And we already, yes,
What are the chapters that we
so exam 2 will cover everything up to the penultimate session, okay? So everything second to last session before the exam. So we'll have a session the Thursday before the Tuesday exam. That is not stuff that you will be expected to know. But you will be expected to know the stuff that we covered the Tuesday, the 1 week before the exam. The Tuesday
So the
before.
14th is the last day that we need to know.
That's right, and you'll have stuff due that Thursday before the exam. That is where the content ends. Okay? Okay, yeah, I don't know the number right now, but if that's what the syllabus says, that's what the syllabus says.
It's starting here.
Well, primarily focusing on what we covered since the last exam, but we didn't forget about equilibrium all of a sudden, right? It's very cumulative. Okay.
What are the numbers?
There's something called flow. So, this is the syllabus. Okay? So, we're responsible through absolute maximum shear stress. Okay? Which is related to max shear stress, by the way. Okay? So that would be session 20. All right? And the primary focus would be from essentially, everything. We didn't have a chance to really knock out some stuff about torsion 2, right? Because that was before the last exam. All right, so we haven't covered twisted rods. I don't think we even really had angle of twist on the last exam. I think I completely said forget about it. Okay, so pretty much from here to session 20. All right. So we've been talking about stress on an element in a structure. And we're pretty much talking 2D, although we know how to handle combined loading, and we can come up with stress in a 3-dimensional state as well, okay? So at this point, right, we've been discussing what happens when you have shear stress, right, and what happens when you have okay? And these are the conventions that we use when they're positive. Now, at this point, what can you do if I say rotate? What are your options? You tell me. How do you handle it? If I want to know what the new sigma x prime, new sigma y prime, new tau x prime, y prime, what are your 2 options, essentially? Yes?
You can make a cut perpendicular to your x prime,
Yeah.
or a cut perpendicular to your y prime.
Right. And if I care about tau x prime, y prime, right, I can use either one of those tests, right? Tau x prime, y prime will pop out nicely, okay? But sigma x prime, I need to do a cut, like you're saying, perpendicular to your sigma x prime, right? And we've kind of defined what the thetas are for the rotation of an element, right? And then figuring out what that new state of stress is going to be on the rotated element, okay? So that's one way to do the cut. What's the other way? The other way? So do cuts, that's one way. What's the other way? Huh? No, well, the cuts is sections. Come on, you guys are doing it. You were doing it. You were not doing the cuts. I know how this works. You were using. Okay, yes, follow that. Whoa, no, I'm overthinking this, Federico.
Trigonometry? Wait.
Yeah, well, yes, we're using. So you just have the transformation equations, right? Right, you can do the cuts, or you cannot do the cuts, right? And many of you chose not to do the cuts.
I did it for one, and it was very fun.
The cuts were fun. Some people like doing the cuts, some people really hate them, okay? So you need to know how to do it. So at this point, right, there are two ways to do it. You have the geometric cutting that we talked about in equilibrium, and you have the opportunities to just plug it in, plug and shove against the equations, right? Now, today, what we're going to talk about is mostly using the transformation equations, okay, to discuss how to calculate out the maxes, all right? So what we're talking about is a state you can rotate to a state such that we get what we call maximum principal stresses. Okay, and notice how it's spelled. Yes, there are some principles here, but no, that's not what we use. We use the principal. Okay? So this would be some angle, okay, that we often designate as theta sub p. What's interesting here is that there's no shear stress. Okay, there's no shear stress. So this is a state which has been rotated with no shear stress. Okay. So the first half of the video notes, what you'll see is I say, look, use Colab, make your life easy, plot the thing, all right? So you should be using Colab, all right, with the transformation equations, and then voila, where do you have zero shear stress? Okay, or where do you have peaks in the normal stresses? And that will give you the state of maximum principal stresses. Any questions on this? So what we're saying is, if I plot say sigma 1 or sigma x prime and sigma y prime, okay, I have something that looks like this. Okay, and this is really bad, but you know, you get the idea, right? One of those is sigma x prime, one of them is sigma y prime. What is on the x-axis? This is the theta, right? And then if I look at, again, this is really bad, okay? You forgive me, please. Okay, if I look at the tau x prime y prime, I have something that looks kind of like that. And what we're saying is maximum principal stresses happen when we have no shear stress, like at these locations, and then you can know what that angle is, and then you can plug it in here and figure out what they are, or it happens when they're peaks, okay? That's when you're gonna have state of maximum principal stresses. And I'm sorry, those graphs are really not great, okay? But if you want to see some good graphs, I guess I should just go to them. Here they are, okay? So here's sigma x prime, okay? Here's sigma y prime, here's tau x prime y prime, okay? Make it easy, just punch in. If you're having questions about Colab as we walk around, okay, we can help with that today, all right? This is a good time to just make your life easy and hit Control Enter, okay? That's all there is to it in many cases. I mean, you got to put in a couple numbers, right? But the example actually does quite a bit for you. Okay, so the state of max shear stress is as you can imagine. Okay, is some rotated state. Okay, there can still be principal stresses. There can still be sigma x prime and sigma y prime, okay? But we get okay? But this is a state where we've rotated by some what we usually call theta s, okay? To get max, and I should say this is in plane. Shear stress, okay? Spoiler alert, this is not maximum, absolute maximum shear stress. This is maximum in-plane shear stress, okay? And we'll talk about what absolute maximum shear stress looks like later, okay? I think tomorrow, no, maybe the next day, okay? It's not that big a deal, it's not that complicated, but we're gonna do some exercises where we look at the maximum in-plane shear stress. Okay, the other way, right? So this is we're using Colab here. Colab, or just really the transformation. What am I saying? We're plotting transformation equations. And it's actually kind of fun, okay? Believe it or not, it's kind of fun, right? You hit plot and you're like, ooh, there's a nice plot. And then you just look at it and you're like, ooh, that's where I think it is. And so like for those of you who don't want to do much algebra today, you know, this is like, ooh, pretty graphs, okay? But the other technique, what is the general, so the other approach, okay, is to use transformation equations. Now, here's a general question. You've taken calculus. What are we looking for here? Are we looking for peaks? We're looking for peaks. How do you find the peak? If you have a function, how do you find a local minima or local maxima? Take the derivative and set it equal to 0, right? Okay, and so that will tell you, okay, where you have a local minima or maxima, hopefully, right? How do you figure out if it's a local minima or if it's a local maxima? How do you figure if it's a maximum or a minimum? Huh? Concavity. How do you figure out concavity, Chris? Take the second derivative, okay, and concave up, which means it would be a minima, negative, yeah, okay, good, all right. So you would take, so these equations are given, all right, you take the derivative, all right, set to 0, find local minima or maximum. Okay, and that's what you see here. If we go all the way down, all right. Whoops. Keep going. Keep going. Keep going. There we go. All right. So calculating in-plane principal stresses. Right. Here's the transformation equation. Okay, and we take a derivative and we set it equal to 0. Okay. Any questions? Any questions on what we're doing today? Okay. So we'll go around if you have questions, right? This is a good time if you have questions about the questions from the previous thing that's due today. We can go over some of those as well. I just need a couple of minutes to get the attendance together. All right. I apologize that I'm behind on that, but give me a couple minutes to do that, and we should be good. So Praj is here. If you have a question, raise your hand. We come around. If you have a question, talk to your teammates, your classmates.
That's why, you see that egg cover?
Professors,
Yes.
our lab's still, they're still going on.
Yes.
So I have lab on Thursday, so I just go to the
Yeah.
under
Yeah.
education.
Thank you for bringing that up, Federico. And yeah, you know, the labs are still going on. We will have, you know, if you missed it or something, sign up again, all right? We have some extra slots. We don't have enough extra slots for the whole class, okay? But if you missed it for some reason, make sure you sign up and get over there.
Professor,
Yes, Chris.
when are the office hours? Again.
Mondays from 12:30 to 1:30, and Fridays 2 to 3, and then Proj has office hours on Wednesdays. So you can get this class every day of the work week if you
Let's
like.
go. No,
Alright.
because I need to I don't feel like I internalized like the subject after 16. I just it ain't click. It wasn't
Okay.
clicking.
Yeah,
So
well, let's talk.
so
Let's
I'll
talk.
I'll see you Friday
At 2.
at 2.
Yeah.
In your where's your office?
In D103.
Okay. I'll see you there.
I'll see you there.
What's Steve?
labs for the tensile?
Same exact time as class.
Okay.
Yeah, so we'll talk about that in a second, all right? We'll talk about that. Okay. Okay. So, just a couple of things. You would have your attention just for a couple seconds. Okay. So, there's a question about the lab. The labs, right? Those are happening at the same time as this, right? And so you can get, if you miss anything, you can get it from the YouTube, right? That we have. So you're not going to miss anything, and that way we don't have lots of scheduling issues. So you go directly to D123K, all right? In terms of, I understand I'm behind on attendance, okay? We will get it worked out. Please do not stress. We'll get it worked out, okay, by the end of the semester, but hopefully sooner, hopefully this week. I'll get at least up to date. That said, if you have technical questions, all right, I do get to those faster than I get to attendance questions. All right, anyone that has sent me technical questions, unless it was in a group meet, all right, has gotten a response. Okay, so we're up to date on that. Okay, so just as a note, I do care about attendance, but that is not the priority. If you have a technical question, you can expect a response through Canvas. Okay? Just wanted to point that out. Great. Yes. Right. What I'm saying is, if it's attendance, I'm behind. If they are technical questions, I am up to date. Yes, that's what I'm getting at. Okay. Yes, sir. Okay. You guys want to do that one?
Probably not next class.
Oh, you're smart.
Okay, questions? Any questions?
There's an equation.
You do it.
So let's do I've been doing this all day, and
Colors are weird.
and then for all of this, when you raise it to 5 kilometers, all you have to do is take the external so that's the
Another announcement. Another announcement. What is happening on Thursday? There was an announcement in the campus. What is happening on Thursday? Meet and greet. Okay.
Oh,
So if you are a junior, it's a great chance to network and get some free food. If you're a sophomore, it's a great chance to network and get some free food. If you volunteer.
bro.
So, what you won't necessarily have, if you're saying don't bring your resumes, right? Put on the side, there's gonna be like chance to stop meeting people, right? But if you're a sophomore, we're still looking for some good volunteers. So you get to see the event, scope out the venue, that next year, and the year after that, you're missing, you can go at it full blast, okay? So, juniors, if you haven't signed up, please do. Sophomores, if any of you, we only need a few, but if any of you are available to volunteer, and guess what? It's the volunteer will be like right before this class and right after this class over there. So it's not that hard. Not that hard. So send me and John Serino a message if you are available to help. And if you are a junior, just click on the link there. Thanks. Any questions? Questions? Yes.
New Jersey Space Force. It's only five, right? But it's also picking up. Don't have it. So now, you do need to find out what's going on.
Right now, in the way we want to
So this term rest is yours. Just copy down. Right. This cosine of 2 times 90 degrees. So cosine of 0. Sine of 2 times sine of 90 degrees. So it's just this.
So it's like 80 when you graduate, like as a student, it's 22 when you graduate.
So that's like see whatever. No. It's like I mean, so on average, it should be in set to the 6. Problem 81. That's more reasonable.
So there was 130 graduation.
I did not. I'm a very passionate person. What's the meaning?
Oh, actually,
so that's not.
Is that it?
One question.
Two gave me the most one. That being said,
And we try this side.
there is.
No, you're good.
That's okay, that works.
Two is also sus. 3 is also sus.
So we could do
17.3 is. Unless I look at it.
Okay, what we're trying to do, see that line is parallel to X line. This line right here is parallel to Y line. Okay? And this one is shorter, so this segment, yeah, that's better, right? So, look, this data, very good. Which is the narrow width. Yeah, that's right. So that's the angle, that's why it's equal.
Have you heard this shit? Yeah, this
Okay, so that, so this is sigma x, right? So then this, if I want the one that's in parallel to y prime, I want this one, right? And that's sine or cosine. So the theta's there, that's sine.
Yo.
Exactly, right? So now, this component right here that I'm figuring out is sigma x times sine theta. Okay? Now, look, this is going, this one is actually connecting the other way. So this is going to be
Really help, please.
yeah, it's on positive y. Plus sigma x
My guy.
sign, okay? But we're not done, because this tracking on this page is vertical face. Now, vertical face, how does the vertical face relate to the
I want to.
How do you relate? This is another time.
Really should know the convention.
So we got delta A, this is hypotenuse.
We both know a guy.
I know several.
Right, hypotenuse and then the angle.
We don't want to.
Weedle did mine.
Use the bottom side.
He actually, because I didn't use that. You know my weight to me? Yeah, he's one who shot it out.
So the bottom one would be sine, and this is where it's cosine. Exactly, so then it's delta A times cosine. Okay? So that is consistent x. That's how we can consistent x.
That's 16, that's 30.
Then you gotta go through, you gotta do how it's like here, how it's like here. But guess what, this problem, there's no how it's like, right? How it's like here. So you just knock it off to the next line. So again, you gotta draw two triangles, or draw a triangle that has parallel lines. Pretty good. Okay, that's, I'm gonna use exaggerated. Exaggerated, so. So like, it's not, these are not exactly parallel, right? This is definitely not parallel to that. Right? So that is too short. Kind of parallel, sure. But I'm thinking, I don't know what kind of. So if I make it super narrow, so that means we can. So then we put again, with the hypotenuse, right, right angle, I know that from the y direction, y prime direction.
I know, I saw. Thank you very much. Section 17. I did. So I used that real line on one side, but I also then is this question?
Verse 17. Yeah, it's question 2. I did it. I wrote it at
Did you get
7.
both of them right?
Yes.
How'd you do? What did you get for part A?
For part A, for which one? X prime.
Yeah.
Sigma X.
Yeah, because I got 61.
Well, I got mine. I had a different problem statement, but
What'd you get?
I got 94.
Which row?
But
Notice that delta A.
Okay, it's right, but how did you do it?
That's right.
No, I want to know how.
okay. Well, this is what I did. I used a lot of trigonometry.
Do you mind if I just look at your work? That's fine.
Hopefully you can read my.
I'll try. Where does it start from here?
Any other questions?
Ignore this. Ignore this part. This part I did the angles pretty fast.
Yeah. I'm gonna consider this shallow. So, F prime x, sigma x prime times delta A, that makes sense, minus sigma x cosine of theta.
What the?
It's all gone.
Get something.
It's all gone. But
Yeah, wait.
it was.
Are you back?
Yes.
Wait.
Oh, bro, my bad.
Yes.
I'm very confused by this. Triangle right here. Right there.
Okay.
Yeah, that's a little weird for me. Like,
All
why
those
is it for-
triangles, those are
plus y. That's not okay. Sorry. So this is 6 x. That makes sense. Okay, I understand.
The first question is, okay, sigma n goes until you get 0, right? And
So
maybe you have a
so we want to try to get how it's going. So I would say try and guess. Like within 5%. So you need to change it. You have to test it. So try going to get this.
how okay, so that's nice to know, right? What's the why? Yeah.
Because I calculated it at 0, I didn't hide it yet.
Yeah.
And I was like everything is this.
Yeah. So sigma y is equal to 0.
Okay, so it's pretty much.
Yeah. So for question 3, I guess you can use that equation. I want to use the graphs.
Yeah, I do.
But that one should be the
That makes perfect sense.
I was gonna figure out, wait, when I did nothing.
Yeah, there is nothing. You're absolutely right. There is nothing in the
So
law.
I was, but I was not.
Yes. Okay. And then,
I only did it for 6 hours.
okay,
So
other
math
question.
is like
Other
I
question.
tried for like a straight hour just to alone and I could not get it. And I was just I was tweaking. Do you
I've
mind
been
if
on
I
this
take
problem.
Do you mind if I take a picture of this?
I did not mind.
Okay, good.
It's taking me 3 hours to do, and I'm still thinking.
Did you get 3?
Yeah.
So this
I'll run you through
is has students that that means that's
Yeah.
So yeah, so that was kind of the angle location. Well, this you don't even need to, this is a separate equation, you don't even need that. This one is starting with that tells you the angle.
We don't necessarily.
Well, I didn't ask it, well, what was the question? Depends on what the question is asked. You should be able to answer both.
Yeah, like for this.
Yeah, so this one is saying, oh, right, so this is, that's where, so what happens?
This is not regular phase.
How is y is 0, right? And then the arc and, what's the arc and? Well, actually, you can do define arc. Has to be 90, right? Oh, it's y over x. Right. So that means that x is 0, so it's minus. Alright. But then you have to divide that by 2. Right? That leaves, does that make sense?
Yeah.
You're working on 3, right? You're not working on number 1 or 2. Okay, so for this, you should be using Koa when we kind of block.
Oh, I thought, okay,
Yeah, but that's okay. I mean, that will give you the right answer. I just want you to get a feel of what's happening.
Consider a cubic.
Okay?
This is the x-axis, this is the y-axis, this is the
Other
z-axis.
questions?
Along this plane is there's a shear surface.
Yes.
I have one question real quick. Did you download
In this situation, I
the
rotate
NP from
90
the number
degrees
pi?
about the positive x-axis,
Yes.
such that the z-axis is now negative 1.
That's fine. That was fine. Professor McConnell's class is for us.
Did the x stress
Yes,
change?
this is also important, but
So that's 50.
I've already done the
So now,
questions due tonight,
turn
so
over.
I'm good.
Now,
But you know the NumPy
the z prime.
installment thing. We have to download it for the Colab, or
No. So if you just do import NumPy, so
So TXZ is the shear stress in this direction, right? It's in this direction. It's all this piece. So when I rotate rotate it again. So it's this. Now what is it? So that means there's a shear stress. The original shear stress was TXY.
That's TX.
No, it is. I forgot the justification.
So it's just at the top for the equal. You do import numpy as np, and then it brings it in.
Okay.
Yeah. You don't have to do anything besides make sure that you run the first cell. You know, make sure you run that before you run the other ones.
First cell.
So I mean, like
Isn't the matrix?
so you're gonna run this first, okay, and then you can run the rest of them.
Oh,
Okay, so then you can run, for example, this one. But if I run this one before I run that one, I'm gonna run into mistakes, or I'm gonna run into errors.
okay. Oh.
Okay. Yeah. And then these are the plots that it spits out.
Okay.
Right. Good. 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 Other questions? Seems like you guys. Oh, where? Where? Come on. Okay.
Didn't we already do this in first section? I think like the angles and stuff, like there was some notes on it, but like graph.
17, I think that one, yeah.
So.
No, is this from 17 or 18?
18.
But 17 is done.
I have it in notes.
I mean, we are just continuing the same thing. Stresses and the planes.
This is from 17.
It's the same thing as stress
I don't take enough notes. For this class, I take notes.
You have the notes.
Yeah. Would you recommend taking notes, like, taking too much, just like more just practice?
Practice. I don't think. Because it's all there. I just do stuff.
I think notes help me more when if I just stare at it, I might get zoned out.
Do it like the day before the decision, right?
Which is in 2 weeks,
I
right?
want to go rock
Yeah.
climbing. I was rock climbing to start with.
Is your foot okay to do that?
No.
Yeah. Okay. Well, maybe don't.
I think you should listen.
No, I want to play football. Where you go? On the break. If you're playing.
Yeah, okay. Just like you're just getting these things like
Like during the break.
I agree, that was kind of like, we're eyeballing it all right. Maybe it's just-
Oh. Yeah, let's running, yeah. That's a sport.
That's when.
I think so.
November.
Swimming?
That's
I know how to swim.
No.
I haven't done swimming.
It's like the only time
Me
you
too.
really
I should go
feel
swimming. Especially I think since I'm tall. Swimming is good for my back posture.
Thanksgiving break starts.
It's just a lot of back strength.
I'm dipping.
Just hang on, I'm pull apart. A lot of back pain.
Okay.
Yes.
I need to find a pull apart. Like, hang on first.
My dad's.
I think it's like computer parts, you find some.
Yeah, the 21st after back then is the best one for me.
I went up to the wall. I don't know how, but actually.
Nobody's
I
interested.
just need rock climbing on random shit. Not even time.
I don't know. I actually had.
Went to one of the birthday parties, like rock climbing was there.
Yeah.
A lot of other stuff, but that was like that ninja and kind of that section, which different, you know,
Oh, what is that?
exercises, like ninja warrior type exercises.
Oh,
Like,
like opposite.
Yeah, I was able to do that, pull up a rod and go up.
I am good.
You see, there's pull up bar, and you have to push yourself and then
Oh, wait, so you come on the board. Move the bar up.
yeah. And
That's actually fine.
you have to basically pull yourself up and then throw yourself head
So you use some lower body strength as well.
and now shoulders. If you're able to pull up,
Oh yeah. Now. I mean, I think I could do like maybe 2. I'll do some push-ups right now.
yeah. Not as good as the thing, not the official version.
Alright. Enter the arrow.
Cannot tell me they do not. They do. Super's everywhere.
Raj has impeccable boot taste.
Yeah.
Those were good.
Kind of. I was like, I'm gonna eat, and then I'm gonna sit with BSC for like an hour doing the adventures.
What if you go gym first and then eat?
I haven't eaten anything today.
Eat a quick snack and then go.
I need to like.
Do you like sardines by chance?
Get a protein shake.
Oh yeah.
Get a protein shake in the gym. Go gym and then come back and then eat a full meal and then come back.
I'm just gonna eat. Okay. I'll let you know when I'm busy.
Yesterday I went for a run and before that, like I was on a fast for like 8 hours, but I ate the Starburst.
Eat a Starburst, a singular Starburst.
I don't know how you do it.
That's it. Sugar rush. And I was able to finish the same distance in 1 minute less.
Crazy.
I told Trevor about it and he was pissed.
What's it's not real?
I on Teams like sent him a screenshot of my stopwatch. He was like, not real, but I scored a shot. He was like, I'll take that off him.
That's funny.
How was the interview?
So it went well.
How when was it?
Actually around this week to next week. Yeah, I mean, so we'll see. It's just I don't know. There's another kid who I really don't like, but he's also you could just get that.
He also
And then
got
he interviewed with the same guy. You might know him, you might not. I'm not giving out their names. So, or do you know what company Okay, because the less information I give up. No, it's not my name. Stop guessing. No. Yeah, yours.
Well, we're gonna have extra ones.
We'll see.
So that's fine. These are probably right, so let's break down cows. Cows, so again, I try to make
I
it.
hate you. I hate you. I hate you. That's mean. That's mean. What?
Yeah. No.
Yes.
NASA?
No. 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 This stays between you
I assigned data acting on. Mine.
It's
This one here.
It's a German company. Rhymes.
Acting on the delta A.
It's a German company.
Assigned.
Oh. Goblin Bees.
No, because it's what Auburn to how it.
Open these nuts.
Okay.
Don't even laugh.
It says it was parallel to Wi-Fi. Good. Good, good. Other questions? You are rocking. top it, well, maybe this won't be it. Kevin.
Not so. Like 7. So 10.
By the way, one of my
Yes, questions?
I only did it for one of the parts. Because I was like, this took me too long to do it, so we'll plug it in.
Because if you do the method of sections at least a couple times, you're not going to do it for the rest of your life. It like helps you understand where it's coming from. Like if you rotate any element by any amount, it's like it's just equilibrium.
I think the formulas were from last session.
Yeah, we do show them after you do method of sections, and we show the general. The general equations are based on method of sections.
So we already did that. That's why I was like, yeah, this is from last session.
Oh, for today? Yeah, today they're not doing that. Today it's equation and COLA.
But last week when you were not around, like I was waiting for you at 6:30. I just confirmed that when I made my slide.
Good. See you, Anthony. Have a good.
Up till that point, I didn't even know how to play this assignments. I just copy pasted one of the attendance and changed it.
That's all I have to do. You did fabulously.
One question, I mean, it's not like one of my friends wants to join the master's. So, which part is, I really wanted to work with people, but the question is if it works with me, or one must say is working with in a different something for a teacher. So
Well, we got multiple things going on. We can always find another piece. I remember thinking about that. This is great. This is one from that. My initial gut feeling is that we need someone to take Duran's project because
okay,
right?
sounds good.
Yeah. So to kind of get the paper published.
And he does a lot of consults.
Does he?
He is working with the president right now, but he has like the editors are not meeting. Professor President was given for a long time. He has some issues. He wants to graduate by probably next year. By the end of next year, most probably.
Yeah, we need to start soon.
I can bring it tomorrow. And once he made his mind up, like switching. So Dhiren's project, not plasma stuff.
Stuff is always good.
So here's a question. If you know in the plasma thing, give me and him a target that when it finish this and you'll be done with the thesis.
Yeah.
So we can just start working on that.
Yeah. I mean, the other thing is, we're probably going to be doing, the rupturing membranes is kind of the new and exciting thing. One of the new and exciting things. Get it to the point
We
where
can work on Dhiren stuff manufacturing. That'll work. So whatever it's done here, we have many people.
no, she's fine.
She's fine.
She's fine.
You need to like kind of push her because she is not big creative. She isn't does. I have been pushing it. I've been pushing it.
This is being recorded, so.
It's fine. She is not going to watch those like. But yeah.
No, we are doing a good job. We're doing a good job. Figure it out.
So yeah, I calibrated it. So we know what this is. The numbers are not coming from a table and it's not adding up, but I think I'm doing some calculation.
Okay.
You're not doing it. That's okay. All right. I thought since you were still here. Yeah. Since you're still here, I thought like
You were doing it though. You were doing it.
you were. I saw you doing it a few minutes ago. That's the other thing. Oh, okay. Do you have any questions?
About Wednesday.
What happened? You're working on it, okay.
Yeah, we actually are.
You actually are. Do you have any questions? Any questions? You're not trusting.
The lecture. I mean, if you compare 17 and 18, 18 is easier. Because 17 they have. And it's almost done. It's just 25 is total.
Well, no, we have. Have a good day. You too.
All right, night.
From what I've been before class, I was outside, was talking with one of the students. It's like getting same things from they don't want to watch videos beforehand. It's like I don't want to do stuff outside of lecture. So if teaching is to be done, it should be in the lectures. And like he should like he does explain stuff, but it should be long. I think we can have like alternates like in 1 week. Right now 2 lectures. Teach them just in 1 lecture, and next lecture is just for like 2 assignments combined, and then during that time they can ask them like questions. I don't know. But up till that point they might have underdone what was being taught in the previous. So I don't know. Instead of doing half hour, wait for the full class, and next is the stop and increase the number of practice problems. work out after the lectures, and then if they have any doubts, they can ask in the lecture. Yeah, but if we do that, then they won't complete. Like it's like we'll see. Yeah, one is for teaching and one is for practicing.